Discover how you can green your life by building a knowledge base of current sustainable and eco-savvy trends. This series will delve into hot topics, current standards and practices, ways to design better spaces, and specify materials that benefit not only us as consumers, but the world as a whole. Members of CaraGreen, as sustainable materials distributors, and other industry leaders weigh in throughout the series. This is Build Green, Live Green.
Hi, this is Jessica with Build Green, Live Green, CaraGreen's podcast on sustainable materials and trends in the building industry. And today we have Jon Heyesen with Arbor Wood Co with us. And Jon, we're excited to have you. We're excited to be working with Arbor Wood Co. You know, we've known each other through some of your prior ventures, including Arbor Wood. But, you know, we've always tried to find a way to work together. And I'm really excited that Arbor Wood brought us together.
Absolutely. Yeah, we're equally excited.
You know, I know a little bit about the background of Arbor Wood Co., but can you tell our listeners kind of how you kind of ventured into the business and where you guys are today and what's kind of positioned you to kind of be taking on, you know, this kind of a larger role here in the thermally modified wood space?
Yeah, absolutely. So we run and have run for about a dozen years a architectural material distribution company in northern Minnesota called Intextural. I've curated a line of sort of sustainably minded building materials, and throughout that journey, and really through a relationship we have with the University of Minnesota and their Natural Resources Research Institute, we became hip to this emerging technology coming out of Europe called thermal modification. And it made sense for us and had really good alignment with the rest of our portfolio to effectively build a brand and start to bring thermally modified wood to the U.S. market. We've been doing that for about 10 years, which really puts us somewhat at kind of the vanguard of that movement here in North America. It's technology that was developed and really commercialized in the mid to late 90s in Europe. And so we're excited, and it's a good time, and we're definitely seeing the market evolve and grow in front of us, and we're investing in our business and are kind of on a trajectory to really increase production and do some really neat stuff.
So for, you know, just for a little bit of background on thermally modified wood, what does that mean? Because I mean, people are familiar with pressure treated, heat treated, but thermal modification is, you know, it's very pointed in terms of the durability that it imparts on the wood, and the performance increase in the wood. So can you talk a little bit about what thermal modification is, why it's different than, you know, simply just pressure treated wood, and what it does to the wood to make it perform better?
Thermal modification is a natural process. It's a process largely based on just heat and steam. So it truly is a chemical-free process. And it is all about improving both the biological durability and just the general outdoor stability of wood. And what's really interesting about thermal modification is that it does work against a lot of different wood species. So it provides some versatility and some flexibility there. We're talking both hardwoods and softwoods. And some of the science behind it is that the wood is modified in a high heat, oxygen deprived environment. And that high heat causes a chemical change referred to as hydrolysis. And so what's happening is we're breaking the hydroxyl groups. We're degrading the hemicellulose in the wood. And it's primarily about moisture abatement and really changing wood's relationship with water. Because with water and with the naturally occurring sugars and the nutrients that are contained within water, well, that's where we have mold and rot and fungal decay. A lot of moisture stored in the cell walls of a plant are also what lead to dimensional instability, thermal expansion, and contraction. And so by really fundamentally changing wood's relationship with water, we can improve stability, we can improve durability. And because there are no chemicals, there's no preserving agent added to the wood, there's really nothing to leach out over time. So the wood has fundamentally been changed kind of forever at the cellular level. It's really effective. It's really exciting. And again, it works across a range of species.
So if you're making these changes to wood and you're talking about increasing the durability, what kind of warranty are you talking about here, in terms of, you know, number of years that this wood is?
Yeah, so I think a reasonable sort of the general industry understood life expectancy for thermally modified wood is 25, 30 plus years. What happens after 30 years? I think part of this is that the technology is roughly 30 years old. So we're now just starting to see the tail end of some of the initial proofs of concept of this technology. But the wood is, I think, in lay terms, a lot of people think about it as being almost petrified.
Yep.
So with a reasonable amount of care and a little bit of maintenance, there's no reason to believe that thermally modified wood in an exterior application couldn't last well beyond 30 years. But it's not a composite; it's just wood at the end of the day, which also means that at the end of its useful life, it can be recycled, it can be repurposed into anything from biofuel to mulch for a landscaping bed.
Okay. Well, that's great. You kind of alluded to exterior applications. So, in terms of applications of the wood that you make, what are some of the profiles of arbor wood? Planks, and what are some of the applications that it's used for?
The most common applications for arbor wood and for most manufacturers in the industry would be cladding and decking. It performs very well as an architectural rain screen. The technology allows for a lot of different wood species to perform very well in a decking application. It's worth mentioning that the modification process does apply a certain amount of stress to the wood,
Mhm.
and part of the change in the hemicellulose of the wood renders it not quite as structurally sound. So the recommendation is for non-structural applications.
Okay.
So, for example, we would not suggest somebody frames their deck in thermally modified wood or in arbor
Yeah.
wood, but you would
Yeah.
use arbor wood decking to deck your deck. You can use modified wood for a railing, for a pergola, for sunshades, things of that nature. Really, non-load bearing structures are absolutely appropriate. We're also seeing really interesting industries and interesting use cases evolve kind of every day as people become aware and really tap into some of the attributes of modified wood. For example, luthiers, guitar manufacturers,
Mhm.
even stand-up paddleboard manufacturers, ski manufacturers, furniture manufacturers. They're starting to explore modified wood for its stability, for its durability, and oftentimes really even just for the color, which is a funny attribute to talk about. But because we're cooking wood at a very high temperature, the wood takes on some really beautiful tones that
Yep.
are really baked all the way through the entirety of the mass. So now you can start to kind of replicate some of the exotic woods that historically would be sourced, say, from a rainforest. But now you can do it with domestically sourced and responsibly harvested woods.
That's a caramelization, right? Kind of that's happening with the sugars in the wood.
That's right. That's right. Yeah, the sugars are yeah, caramelized is a really great word. There, it's we're sort of roasting the wood, and so this, for example, is our thermally modified white ash. When you see this sort of green, it's very much a blonde, just natural
Mhm.
wood color. There are no pigments, there are no dyes to sort of get to this really pretty color, but this is just what happens as part of the process.
Yeah, we prefer brunettes over blondes anyway. Anyway, so outside of the ash, what are some of the other species that can be thermally modified? Because I want to talk about chemically modified wood in a minute, and I know that they're relegated to mostly one species.
That's right. Yeah. So thermal modification does work against softwoods, hardwoods. We have modified perhaps a dozen different wood species, anything from red oak to white ash, aspen, maple, basswood, southern yellow pine, eastern white pine. And so the versatility of the technology is part of what was really interesting and compelling to us. And for a lot of manufacturers, it allows us to take almost a hyper local approach to a given project
Mhm.
where we can even explore the use of trees that were maybe felled from a construction site. And we can take those trees in turn, put the value add on it, mill them, and reuse that wood in the construction of whatever that building happens to be. Also just thinking about the 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 well understood supply chain issues we continue to see sort of globally across all industries. And thermal modification allows us to quickly pivot and sort of adapt our product line to potentially a wood species that has greater availability or is growing in abundance, or if we see certain say insect infestation that's impacting a certain species, say like the emerald ash borer, something we're paying attention to, that should that negatively impact and really shut down the availability of ash, well, we could flip to something like a red oak. Talking about a lot of the more natural, albeit chemically preserved wood modification techniques like acetylation, like
Mm-hmm.
furfurilation. Some of the brands would be Accoya, would be Kebony.
Yep.
Those processes are basically a chemical impregnation process, and they really only play with softwoods, and that's why you'll see radiata pine kind of
Mm-hmm.
exclusively as a species
Right.
used by a lot of those brands. Yeah.
Right. So the chemical modification, in some cases it kind of swells the wood cells, but it does, it requires kind of this sort of outside influence, and it does have additional equipment used to create that process. But my understanding is that some of the starting material, it may be sourced from a responsibly managed forest or plantation, um, and I mean plantation in the sense of a lot of trees planted there. But they travel a lot. Like sometimes the wood starts in the Carolinas and ends up going to Europe and then maybe comes back, or New Zealand. I mean, is my understanding correct that there's kind of it's a well traveled species? It's a well traveled process and species once you get this Accoya or Kebony wood.
Yes, yes. And even some of the European manufacturers of thermally modified wood are sourcing their timber from North America, bringing it to Europe for modification and finish milling, bringing it back into the States. And so, part of the value proposition of these modified wood technologies is all about building materials that are gentle on the planet. And it's all about
Mm-hmm.
reducing the embodied carbon on a given
Right.
construction project. And when you talk about the logistics carbon footprint as part of production, it really kind of starts to shoot some holes in that value proposition. And yeah, when we look at the Accoyas, when we look at the Kebonys, some of those techniques, and talking on acetylation, for example, it does expand the cells of the wood. It kind of improves the capillary effect and allows water to move more freely through the mass, but it doesn't necessarily directly improve biological durability. So it's not sort of changing the wood's relationship with water, other than allowing it to move more quickly through the material. So it's reasonable to think that the performance of thermally modified wood is oftentimes superior to some of these other processes.
Okay, and I think I like the way you say that it changes. Thermal modification changes the wood's relationship with water. I think that's kind of a very kind of concise way to summarize the value proposition. Another thing I wanted to ask you about was the finished look. So I know sometimes when you get some of these products, when they're left to weather based on these modifications, often they turn to gray. Look at wood, any old barn. I mean, I grew up in a 200-year-old farmhouse, and everything, all the wood, of course, had weathered to gray. But does that happen with arbor wood as well?
Yes, it does. It does. So the process doesn't improve UV stability. In fact, I believe that arbor wood tends to lighten faster than, say, traditional non-modified woods. A lot of the naturally occurring tannins and the compounds that give wood its color are some of what get cooked out during the modification process. But a lot of people really like that aesthetic.
Yeah.
And for folks who want to let arbor wood move to gray, it could really largely be considered a maintenance-free natural wood product. But it is also possible to maintain these tones, and there are fairly standard off-the-shelf finishes that work really well with thermally modified wood that would allow somebody to maintain these beautiful, rich amber tones. And I always like to remind people, kind of looking at this sample again, that these colors are through colors. And
Mm-hmm.
so in the event that the surface of say an arbor wood facade started to move to gray 3-4 years down the line, it is possible to restore this original color through just a gentle sanding, light pressure washing, something like that.
In the fade to gray with thermally modified wood, while in other wood types that fade to gray would occur with some degradation of the wood itself. With thermally modified, you're not getting that. You're getting a very durable piece of wood that's the color is changing to that gray, which a lot of people like and use it for that silvery gray. But you're not getting the kind of the breakdown that you normally would with the over time with the standard wood.
That's right. Yeah, you don't really get as fully a weathered looking board. It's really just silvered out, but the physical integrity of the board remains.
Okay.
Yeah.
Okay. So there are no chemicals introduced. So it is, very, very natural. What are some of your kind of favorite installations that you've done, that you've had, that you see that you're really particularly proud of?
Yeah, one of the largest installations that we've been a part of is here in Minnesota. It's the Bell Museum of Natural History. It's on the St. Paul campus of the University of Minnesota. It's a LEED Platinum building. It's a net zero building. It's won a bunch of awards designed by the talented folks at Perkins and Will. And that particular building, very large Arbor Wood facade. It made use of Minnesota grown Eastern white pine that was sourced within 2 hours of the job site. Very, very cool. And the university, just sort of as part of the ethos of the museum itself, they wanted the building to represent really a living and organic structure and experience. And so they wanted thermally modified wood. They wanted to leave it raw. They wanted sort of the effects of the sun and Mother Nature to do its thing and allow that facade to just gradually move to silver. And it's been fun to watch that building transition, but very beautiful building. There is a project also here in Minnesota at a public park system, Theodore Wirth Park,
Mm-hmm.
and the city of Minneapolis connected with Arborwood to repurpose boulevard ash that were impacted by the emerald ash borer. And so these
Mm-hmm.
trees were all getting removed anyway. And we were able to take those trees, modify them, turn that wood into decking, which was then used for some public sort of boardwalks and walkway systems throughout Wildflower Sanctuary within this park, which is just a really neat story and kind of a testament to the technology. But we're seeing modified wood anywhere from Brooklyn Bridge Park, and you have public parks that are starting to take advantage of this. We're seeing large retailers that are incorporating modified wood on storefronts, and so really kind of throughout North America and really largely throughout the globe, modified wood is becoming less niche, and so more and more people care about the materials that are used in their buildings, in their homes.
Yeah, I mean, I think we've seen wood make a real resurgence here. As people talk about, biophilic design, and, people, for a long time, what was seen as kind of the sustainability story of wood was, FSC, that it was responsibly harvested, and things like that. And I think you've taken, thermally modified is this really natural way to increase the durability. It's also local, responsibly harvested, multi-species. So you've kind of really expanded the sustainability story, and, kind of telling that story in some of these jobs that you're talking about. People really connect to wood as a product. And when you can, kind of make it even, more durable and longer life, I think, it's just a natural kind of progression towards using more wood. We see it in a lot of the projects that we work with. It's just people are incorporating it with, hard surfaces and things, because it just imparts. It's the easiest way to bring nature into a space.
Right, right. I agree. And I agree that sort of human beings have this innate need to feel connected with sort of the natural world and sort of the world around us. And for many years, there were materials that tried to replicate the look of wood. We had
Mm-hmm.
composites, we had, wood grain embossed metal siding, for example.
Yes.
And now people can get back to using wood again. There are really
Yes.
interesting technologies, the mass timber movement. We talk about CLTs a little bit as a construction methodology, and these natural wood modification technologies for finish applications that are making wood relevant, making it exciting, and also making it long lasting.
Yeah, like we deal with, a lot in the sustainable materials space. Just in building materials in general, there's a lot of this, copycat stuff. Like, we deal with hard surfaces, so everyone's trying to look like marble, and I find it so odd when you're trying to copy something. That marble's a great example. Marble can't be used in high acid, high wear environments because it wears too easily. So it's been replaced with these materials that are worse, but they look like marble. So people are using them. And it's, just now that materials are coming out that are better, better for the environment, that also look like marble. But at the end of the day, if it could just, in your case, it is the material, right? It's a way to modify the material to address those things rather than come out with some plastic composite trying to look like it. Like you were saying, with all the exterior composite products with the wood grain and so on.
That's right. That's right. Yeah. And I think, in the case of Arbor Wood, we produce material certainly at scale, but it is still just an organic, natural product that will have its
Hmm.
own sort of characteristics from board to board. This is an example of our sort of take on traditional Japanese yakasugi or shusugi ban. We
Yes.
found that the stability of modified wood, in this case, our modified pine, is really a good canvas for applying some of these real charred finishes. And
Yes.
we produce this on a real open flame system. And it is both consistent and unique at the same time. And
Hmm.
so it just allows people to have some fun and be creative and have a sense of personalization or uniqueness
Yes.
when they are thinking about designing their home or designing a building.
Yeah, and I think, and that's a big deal. I think, if someone is building a marquee building, or it's a mountain home or a lake home or something that they just kind of want to put their fingerprint on, and you're relegated to these, vinyl siding and all this stuff, or fake brick and all that stuff. It's just very, it's really neat to have these options out there for them to really choose something that kind of represents what they're trying to do.
That's right.
And then I want to ask one last question, because you don't want people running outside, chopping down a tree and throwing it in their oven, thinking they're going to get thermally modified wood. This is a very advanced technology that you guys have. This is not just an oven that you're throwing stuff in. This is a system that came out of Europe. It's very advanced. There's not a lot of them in the world. Can you talk a little bit about the technology and why it's unique to Arborwood?
Yeah, it is absolutely specialized technology. It is it's very high heat, and the way these systems work are such to either have nitrogen rich or just oxygen deprived environments. The heat is high enough that it would otherwise combust. And what we're now seeing is sort of next gen technology, and part of what we're building over this next year is a new manufacturing facility here in Minnesota, bringing in this next gen technology. Where now we're incorporating pressurized vessels and pressure into the equation, and sort of the inclusion of pressure plus heat plus steam. It requires less energy for modification to happen. It creates more consistent modification and improved durability. And we can do some really interesting things like explore the impregnation of, say, a fire retardant for improved flame spread performance on a natural wood cladding facade. And so the technology is very much proprietary. It's been developed and evolving over these 30 plus years that this industry has existed. And so I absolutely would not throw some wood in an oven. And it is different than, say, a traditional drying kiln. A drying kiln is more about reducing moisture content to a specific level, whereas these modification kilns really kind of create that modification reaction at around 200 degrees Celsius. So we're talking about pretty high heat environments.
And we know that it changes the relationship between the water and the wood.
We sure do. That's the point.
All right. Well, thank you so much. This has been great. I'm excited to see what Cara Green and Arbor Wood can do together. And I appreciate you coming on the podcast.
Happy to be here. Thank you so much.
This is Bill Green, Live Green.